Hello everyone, welcome back to CyberDucky. This is episode 2 of our LearnBGP series. In previous episode, we successfully set up eBGP between ISP1 and the router 1. So in this episode, we're going to add a new internal router, which is this one, and we're going to form a neighborhood between these two under AS200. After we set up a neighborhood between these two routers, we're going to try to reach from this network all the way to this loop back in ISP. And whatever the problem we're going to encounter here, we're going to troubleshoot and we're going to learn and a new informations and new skills we're going to add to our BGP knowledge. Let's start. So let's begin our lab. So I have here ISP ready. So I can see BGP show IP, BGP summary. We have already formed neighboring. And I can go here and try here as well, show IP BGP. And I have a AS part 100. I have the route here. BGP summary and a double check. I have received the prefix. What we're going to do is going to configure the router 2. I'm going to do quickly this part. Let me go and show. Okay, before I do the next part. So if you see here, we are configuring neighboring remote AS is 200, which is same as R1. So this is how the iBGP is formed. So now I'm going to do a show IP BGP summary. You can see here they are idle. Its configuration is done because but there is no any communication started. So what I'm going to do is quickly, let me do one more thing. Router BGP 200 BGP router ID is just configure router ID so that it's easy to just served. Now I'm going to go and configure R1. Okay. Config interface gigabit 0/1. IP address is 1.1.1.1. Subnet mask is 255.252. No shutdown. Then I go to config router BGP 200. Then I type neighbor. Is this neighbor 11.11.11.2. Remote AS is 200. They already have the neighboring up. Okay. So sorry, update. So I just put this one. Okay. Then show IP BGP summary. All right. So I have configured the neighboring informations like remote AS, then the update source. Update source usually need multi-hop, but I just put it because to be safe so that router does not try to communicate. If there is too many different interfaces, it might, I don't want to try to run the wrong interface. So anyway, I done that part. So if you see here, you can see one prefix coming from ISP, which is if we go and say show IP BGP, so we are getting this one, right? We are getting this network, so that's why we have one prefix. We are not getting any prefix from R2. If you want, we can add that 150 router BGP 200 network is share this network, and last case 1.2.5 and save memory. Now if we go to our BGP, okay, now we are getting new IP address, which is 333 from this neighbor. Next hop is this one. This is correct. Local path is there. Later we will discuss the paths and all this. So I just want you to know. So if I ping 333, is it possible it can know? Yeah, it knows. But the source interface again is going from this. It's taking local source interface, this one, to reach all the way to here. So we are this way, and this is the next hop router. the gateway to reach this IP. All right, now, so we have done that. Now we want to see the routing table of, here we will see show IP BGP. The problem we're going to solve today is this one. Okay, there is a problem. So 1111 network next hop is 10.10.1. So if I try to ping 1.1.1, it won't work. The reason is it's showing next hop 10.10.1, but this router doesn't have access to this. Let me change the color, maybe it will be easy to understand. So what it's saying is the routing table is showing to reach this one, your next hop is this, but this router has no idea how to reach there. So to solve this, either we can put one route command saying that to reach this network, you can have a static IP pointing here. This can maybe solve the problem, but this is not the right thing to do. So there is something called next hop self. So what it's basically do is that all the routes coming from eBGP is always advertised with its own IP. So it's saying is to reach this IP, you come via this one. This is how it's advertised to this. So it works here because they are neighbor. So when this routing information is transferred to here, it also it's just send as it is. So this information, it doesn't have this gate information, it doesn't have. To solve this problem, this is one of the problem you will encounter when you're configuring between iBGP and BGP. If you have one like scenario like this, so what you have to do is convert this one to like a gateway, to become a gateway for this. What we will do for that is we're gonna go to our R1. Just remember this part. Now it's like this. Okay, now we go here, config T, and router BGP 200 is our AS number. Here we're gonna say neighbor 11.11.11.2 next hop self. So we have two options. We're gonna go with the self. You can give all meaning iBGP, BGP receive all this count. So we're gonna give this Anton this time. Now we end here, save the configuration. Now if we go to R2 and get BGP show BGP, not yet updated. I think we should have give all, I think. Give me a moment. Now let's see how it's. Maybe it takes some time to form. Let's see. eBGP. Okay, now it's changed. The next hop is the IP address of this. So, but why still we cannot reach? There is another routing issue we need to resolve, because we never share the any other information than 3. So if you go here, we won't see the path. Give me a moment. So IP BGP. Okay, so this is showing that the relation between the ISP and the and the route one is eBGP. So they have shared the correct information here, but there is no any information if to let me get them from here. It's come here. We managed to change the next hop, but still we don't have the reply, right? So we need to solve a few routing issues. So we need to add advertise this route also in this okay. So to solve this, we need to add we need to address few IPs. So one of that is we need to advertise in R1. We can advertise config T router BGP 200 network 10.10.10.0 mask is 255.255.252. Okay, now if you go here, we should be able to see one more is there. Okay, so if I ping from ping 11.11.11.1, we will get a reply. Also we don't get a reply because this one doesn't know where is the 10. Show IP wrong, don't have the 10. So the problem is if we ping dot we don't get. So we need to tell this router. The easy way is just add here. Okay, networks Here we just add the 10 also, so it's easy for the router to get to know. Mask 255, it's done. Right, memory done. So now if we go here, short route, blah blah blah, we can see all of them. BGP, we have the informations. Now if we ping 2, it gets replied. Now if we ping 1.1.1, it will work. So I hope you guys understand what is happening here, right? So first problem what we faced is that is the nature of the BGP when it between two when it shares the iBGP route to its own EGP. When it shares the eBGP route to its own neighbor in the same AS number, it become iBGP. When it does is that it doesn't change, it doesn't share its own IP. It always give its different IP, which is usually the whatever the next hop it's received, it's passed to its own neighbor. To solve that problem, we need to apply next hop self self command in the neighboring command. Then you will see they are able to see the correct correct gateway information. Earlier it was saying 10, and it doesn't know where is the 10. When we solve the other problem, the connectivity problems, from router 2 all the way to router 3, they need to have some information of router. Okay, to reach 10, you need to go here. To 11, you need to go there. Thank you everyone for your time. I appreciate your time, and I hope you have learned something important about BGP, how to configure iBGP, and how to configure next hop self, and how it solved the problem of routing issues which coming with the eBGP gateway problem. And please don't forget to subscribe and share and comment. Thank you for your time. I appreciate your help. Thank you.